Today we're going to be learning about the remainder and factor theorem. It's the same thing. So what is the remainder factor theorem? So if I was to ask, is this a factor of this polynomial? What you would need to do is plug in that number from that divisor, and if it equals 0, it is a factor. If it does not equal 0, it is not a factor, and that number is the actual remainder of that polynomial if I was to divide by it. So this is important to put in your notes. So I'll do two examples here. So I'm asking you, is x minus 2 a factor of this? So one possible thing that we could do is do our synthetic division from the other video, and if I got 0 at the end, I know it's a factor. Another possible way is to use this remainder factor theorem. So that says we're going to plug in the divisor. So what number am I going to plug in here? I need to set that equal to 0 and solve it. So the number I'm actually plugging in is the number 2 in this big equation wherever you see an x. So I'm going to substitute that in. And I'm going to work this out using order of operations. Definitely use your calculator here. Alright, so here I've got 2 to the 4th times 2. I did this already in my notes, so let me find it here. Okay, I get that to be 32. Plus, this is 56. Minus 16, minus 54, minus 18. So I'm just going to add and subtract as they come using the calculator, and the answer is 0. So that means yes, a factor. So x minus 2 is definitely a factor of this big polynomial. Okay, let's move down. Alright, let's do another one. I'm asking, is x plus 1 a factor of this one? So let's get the divisor to plug in. So the divisor I would use, make that equal to 0. I'm going to be plugging in negative 1 for x. So negative 1 to the 3rd plus 5 times negative 1 squared minus 7 times negative 1 plus 3. Alright, be careful with your negatives. So this is negative 1. Positive 1 times 5, positive 7 plus 3, this is 4, plus 7 is 11, plus 3 is 14, so that means x plus 1 is not a factor. That means that 14 is the remainder if I was to go ahead and divide x plus 1 into that. Alright, last thing here is, what if I asked you to work backwards? Let's say I am telling you what the zeros are, what the x-intercepts are, and you have to work backwards to give me the original polynomial. So you're going to form a polynomial. It's of degree 3, whose zeros are negative 3, 2, and 5. So if I was to actually have solve this, right, that means my x's, my zeros would be negative 3, positive 2, and 5. So what would have been the equation before I solve this to get negative 3? So I want you to think about it. What would it have been here that I would get negative 3 if I was to solve it? It would have been x plus 3, right? Because when I solve this and make it equal to 0, I would get negative 3. Alright, let's work backwards from 2. What would that have been originally? X minus 2, right? Because if I made that equal to 0, I would get 2. And for 5, x minus 5. So you don't have to multiply it out. This is my polynomial in its factored form, right? Is this of degree 3? Well, if it's factored, we said we have to always add up all these things. So 1, 1, and 1, yep, it's a degree 3 polynomial. Alright, one more, a little different here. They're going to give us multiplicity now. So if I'm forming a polynomial of degree 3 again, whose zeros are -1, multiplicity for this one is 1. So that means the exponent is 1. And the other 0 is 3. So that means the 0, before I did that, that's 3. That multiplicity is 2. Alright, let's first get these in their parentheses. So this one would be x plus 1. This one, working backwards, would be x minus 3. Now what am I going to do with the multiplicity? Multiplicity is the power, right, that we would have. So do I need to put anything here? Nope, because it already has an imaginary 1. This multiplicity is 2. So that means I need to put a 2 on the outside of that x minus 3. So this polynomial, if I was to write it, would be x plus 1, x minus 3 squared. Now, is this of degree 3? It's factored form. This is a 1. Here's a 2. I would add it up. Yes, it's a degree 3 polynomial.